This is problem 8-39 from section 8.1.2. What is the degree of each polynomial function below? So the degree, we talked about this, is the highest exponential number in the problem. And it's not necessarily just the one that's there. If it needs to be multiplied out, then you might need to do that. Okay? So in the first one in A, I can see the largest number is a 2, so my degree is going to be a 2, which would make it kind of like a parabola. In B, my highest number exponent is actually not in the first spot, but it's 5. It's x to the 5th power, so my highest degree is a 5. Okay? In C, I want to multiply those out. I have 3 things with x's, so I really have x times x times x. I don't really care about the other stuff right now, but this is going to give me x to the 3rd. So my degree for C will be 3. That's the highest exponent with the x. In part D, I have something squared. So say I multiplied this out, it would be x times x. Then I have another x right here. Then I have an x to the 3rd power. So it's not necessarily the biggest number there before you multiply it. You need to multiply it out in order to figure that out. But most of the time you can do that in your head. So I had an x squared from the first term. I had this one, and then I had x to the 3rd. So I add up how many x's there are, x to the 6th. So D is actually a degree 6 polynomial. And we said our degree tells us the maximum number of x intersects. Why can't I say that word? Anyway, that's the maximum number of x intercepts, and it could be less than that. And it also kind of tells us the shape. So part C would look like a cubic, so this will look like an S with a squiggly. This would be like a parabola. 6 is having a lot of squiggles going on, and 5. We also talked about the orientation. So 5 would have a negative orientation, and the degree 6 polynomial would have a positive orientation. So it's the largest number in the exponent once it's multiplied out.